Hey, Wiz, you heard of DSPY?
Yeah, for sure, for sure.
So, like, what is it exactly?
In its most basic form, without kind of thinking about or unlocking its actual potential, it's like a automated prompt engineering framework.
So, it's just advanced prompt engineering then.
Yeah, in its most basic, most unleveraged form. That's right.
But it can do other stuff too?
Oh yes, yes it can.
Oh, okay. And DSPY, what does it stand for?
I think it stands for DSPy.
DSPy.
Yeah.
I've heard Dipsy from others. Uh I've heard a lot of things about this tool, and I'm not quite sure exactly what's going on with it. I think this advanced prompt engineering is a great place to start. So we're going to go ahead and build this up one foundational block, one DSP at a time today. What do you think? Sound like a plan, man?
I think that sounds great. Yes.
Yeah, all right. Let's get into it, everybody. My name is Dr. Greg. That's the Wiz, and we are AI Makerspace. Today we dig in to DSPY. And this is a tool that you've probably heard of, and you're probably not quite sure exactly what's going on. So today we try to get to the bottom, at least the very bottom of it. And turns out it's a bit more complex than even I thought personally. And so maybe there are some follow-on events after today. You'll learn exactly what the story of DSPY is today. You'll learn how to apply it in its simplest, most basic form, and you'll kind of get a feel for how we might continue to apply it in ever more complex LLM applications. If you have questions along the way, go ahead and slap them into Slido for us and upvote your favorites. You can also use the YouTube live chat, especially as we get into Q&A towards the end of the event today. All right, let's get into it, everybody. Let's try to answer the question, is it just advanced prompt engineering? And perhaps answer the question, is it useful to think about it like this? We think so. Let's align our aim for the day. This has kind of really evolved since we started looking into the tool, because there's a lot of different ways to tell the story of the DSPY project. We're going to give you a brief history of the project, how it's really come into fruition in its current state, and hopefully give you an idea of some of the main characters in the story. We're gonna really walk through the core concepts and code to use a simple DSPY program to optimize prompting, you might say, to engineer the prompts for a closed source LLM. We're going to try to make it as simple as possible. And then we're going to talk a bit along the way about how the scope of DSPY has continued to evolve and really does cut across all the prototyping patterns, whether you're talking about prompt engineering, fine-tuning, RAG, or even agents today. All right. First, we're going to talk about the vision of what the creators of DSPY are putting out there for all of us to consume, and what really seems to have motivated the work. We're going to talk about the practicality of DSPY and how we actually break it down into something that's applicable. And then we're going to build a pretty fun application. We call it Dope or Nope. And DSPY, turns out, is pretty dope at optimizing it. All right, so grand scale, what's going on? Well, the creators are really gung-ho about this. They're like, new paradigm of building generative AI applications where LLMs and their prompts fade into the background as simply optimizable pieces of a larger system that can learn directly from data. Based on some of the X threads that we're seeing from folks close to this project, especially Omar Khattab, the author of DSPy. Really, this came out of a long-term vision in the lab that he was working at Stanford, that I believe he's still at before he starts as an assistant professor at MIT in the fall, where they were working towards scalable, explainable, and adaptive natural language processing with retrieval. This is obviously a wide-ranging, long-term vision, and it's something that is, really needs to be broken down into its subsequent steps. So just as a company or a person might have a long-term vision, what's the mission that they are on today with this project? Well, the mission, it appears to be to unify retrieval-based NLP with in-context learning. And this is pretty cool because, unifying retrieval with in-context learning sounds pretty familiar, especially if you've watched any of our stuff in the past, to something we talk about a lot. Recall RAG. I mean, from the very basics of RAG, we're trying to solve the problem that LLMs lie to us confidently. Very, very bad. We don't want them to hallucinate. We want to fact check these LLMs. We want to make sure we can find reference material, add it to the prompt, and get better answers. We want to retrieve, augment, and then do our generative AI. And if you've seen any of our RAG events, we like to break this down into two pieces: dense vector retrieval and in-context learning. The idea here is that when you ask a question, you're going to send that through an embedding model. That's going to turn it into a list of numbers. It's going to be a vector. That vector, we look for similar things in our data that we've stored as vectors, chopped it into chunks, run it through embedding models, and stored it. This process of looking for similar data is going to then take the similar stuff we find, convert it back to natural language, and put it into our prompt, which generally we've set up with some kind of prompt template, potentially saying something like, use the provided context to answer the user's query. You may not answer the user's query unless there is specific context in the following text, and so on. Now, this first piece is where we're doing this vector retrieval. And the second piece is where we're putting our retrieved context into the context window. We're teaching through in-context learning here. Now, one thing that you might say is like, well, is this prompt template optimized? And this is kind of an interesting starting point for the discussion of DSPy. And of course, RAG is not complete until we put the G in RAG. We've done retrieval, we've augmented, and now we need to generate with our LLM chat model to get our better answer. All this is great. So let's go back in time to the first paper, the DSP paper from December 2022. And what the DSP paper said is it said, to begin to, quote, fully realize the potential of frozen language models and retrieval models, we propose demonstrate, search, predict. The paper contextualized all this by saying retrieval augmented in-context learning has emerged as a powerful approach for addressing knowledge-intensive tasks using frozen language models. And what's really interesting about this is if we think about the idea of a language model and a retrieval model, we can sort of separate these two ideas as they did in the paper here, and we can create higher level programs that are sort of based on this idea of having the language model talk to the retrieval model. Similar to RAG, but in a slightly more multi-step manner. And so this is the classic example from the paper. Note in the caption on the example, on its own, the language model often makes false assertions, hallucinations. This is the big problem that RAG tries to solve. And what they note here is that the vanilla language model, as well as the retrieve and then just look at the answer, that neither one of these are kind of giving the right answer. But if you sort of consider deeply breaking down this question, how many stories are in the castle David Gregory inherited, where you might first say, well, which castle are we talking about? Let me get the specific name. Then I might get the specific name. That's going to be more amenable to a retrieval model. How many stories did the specific name castle have? Okay, and we can kind of have this back and forth. So we can break down the problem into smaller pieces, thus solving it. It's kind of chain of thought style, if you're familiar with some of the advanced prompting techniques. So, this is December 2022. RAG maybe hasn't really become like the de facto way to talk about these systems. So we're using words like retrieval augmented in-context learning. A month later, in January, Omar posted this thread on Twitter, epic thread, and this is when DSP was released. The idea was that we, quote, express a large space of AI systems as strategies of exchanging text. So rather than simply putting reference material into the prompt, we're actually exchanging text back and forth between the retrieval model and the chat model. And so the TLDR on this was prompt engineering later, bro. High-level programming strategies, yes. Exchanging text, yes. And automatically annotating demonstrations, yes. So what came next was about 6-7 months later, in August of 2023, DSPy was released. And it was really, again, pushing this, let's move past prompt engineering. And now we were talking on some grand scale here. DSPy unifies prompting, fine-tuning, reasoning, and RAG. And it's like, wow, okay. Really took to the next level. You can see why it's kind of confusing to try to get a handle on this. What's it doing exactly? Well, it's important to note that the DSPy compiler, which we'll look at again in its simplest form today, so we can start off on the right foot here, automatically traces your code and crafts and validates high quality prompts and also fine tunes here. Okay, so we can move down the task specific spectrum for your language models. Shortly after this Twitter thread came out, predictably, we see a paper on arXiv in October. And the idea here was that this paper was really sort of setting the tone for what we all probably started hearing about DSPy as. And this paper was entitled Compiling Declarative Language Model Calls into Self-Improving Pipelines. And the whole idea was that everybody was obsessed with sort of prompting and optimizing their prompts. And they're like, well, yeah, that's cool, but really these hard-coded prompt templates through trial and error, there's got to be a better, more systematic, more engineering-focused way. And thus, DSPy, abstracting these sort of trial and error prompting pipelines into these declarative modules. Okay, so this is the brief history. So where are we today? What does it stand for? Well, today it stands for declarative, self-improving language programs Pythonically. That's what it stands for, okay? The sort of backronym, as they tell us on their GitHub page. Of course, it came out of Demonstrate, Search, Predict, but today it's declarative, self-improving language programs Pythonically. So I just want to, before we get into the simple way to think about this, I want to stay at the high level, and I want to bring Wiz back up on stage. So it seems like, you know, there's this kind of iceberg that we're having to traverse downward with DSPy. It is for prompt engineering, to say sort of put engineering into prompting, but it's also for RAG and for fine tuning and for agents. Like, how do you think about this tool as cutting across these different generative AI patterns? What's the easiest way for you to think about this, Wiz?
Yeah, I mean, so basically, like, when we think about prompts, prompting LLMs, all these things, just when we think about them like conceptually, right? We don't yet have a really good framework or even mental model really to partition or bucket these different parts of a system. So, you know, what we want the thing to do, how it should return values, the kinds of values we're going to give to it, right? Versus the optimization that occurs around that desire, right? And that's going to be true regardless of, you know, if we're in RAG, if we're in agents. We kind of have like, you know, we think of them in these ways, right? As like, this is the behavior that we want, right? And then this is the way we're going to achieve the behavior. And as opposed to kind of rolling those into a single unit, which is what a lot of other frameworks do, I think DSPy really helps us, you know, approach this in a way that's more systematic by letting us actually separate those things out and then providing us kind of levers and knobs to do the optimization in the optimization step that's distinct and separate from our actual desired behavior. I think that's the way that I think about DSPy as it relates to other important you know, concepts that we'll get to in time.
Yeah, so it's sort of abstracting out almost a hyperparameter optimization step for any of these systems. Is that ish?
Right? We have task. We want LLM to be good at task, right? And there's a number of different ways that we can optimize LLM to be better at task. But that shouldn't necessarily be in where we declare task, right? So having the ability to split those apart is something that's really useful and quite a good way to think about it, right? Where it's like this, as we'll get to, like the difference between a signature and a predictor, right, is important because the signature is what we desire, it's what we want, and the predictor is what helps us get what we want, right? And that's the system that needs to be optimized. Versus current strategies where we're trying to kind of do both at once, and or we're doing it in a way that's like relies on the first piece, right? So that if we change the second piece, like it no longer works. I think that's that flexibility.
Yeah. I mean, so when we do RAG, we often say sort of as goes retrieval, so goes generation. So we're sort of almost optimizing for retrieval rather than the actual directly optimizing for the generation and for the
100%.
Yeah.
These are two distinct things in the current ecosystem. I think they're going to remain that way, to be honest with you, but we have better tools. We can think about the systems in better ways that help combine the pieces that we want to optimize for and not combine the pieces that shouldn't have any bearing on the optimization.
So we've recently covered loss functions, and I'm almost thinking about this as sort of a single, almost, you know, it forces you to almost cast it into a more classical optimization scheme that has kind of a single thing that's task oriented that you're trying to optimize. It sort of helps laser it in. Is that another way we could think about this as well?
I think that the DSPy folks in their GitHub, in their papers, would agree with what you just said quite a bit. The idea is that, yes, we want to move what is right now a very feely, very human intuition space. We want to move it back into engineering domain. We want to, even though maybe under the hood right now it's still relying on some of this stuff, and we can talk about that a little bit. But the idea is we're moving toward basically like putting a layer on top of this kind of RAG agents prompting that is more guided by the systems we as data scientists, machine learning engineers, and AI engineers are used to or familiar with.
I see. Okay. Yeah, I love it. So we're sort of making this murky water a little bit clearer with DSPy, making the qualitative a little more quantitative. Yeah, bringing the prompting into engineering. DSPying it up. Really? Okay. Love it. We'll go to the practicality now. We'll be back to you for a dope or nope, Liz. All right, everybody. So I hope you're getting a high level feel for this. And what we're going to do is we're going to kind of zoom in here a little bit. Now, recall they said, hey, new paradigm, LLMs and their prompts fade into the background as optimizable pieces of a larger system that can learn from data. So let's focus in on this prompts as optimizable pieces. Here's an easy way to think about DSPy. It's just a wrapper that we can use to automate prompt engineering. Here's another way you can just think about it real easy and maybe explain it to your boss or whoever. We're putting the engineering back in prompting. Maybe it was never there at all. Now, I found a great kind of meme-ish sort of visualization of prompt engineering, where we have this sort of genius in the room is this mental model where your LLM can only see what you write it. And then you're the prompter. And there's this door that we have to pass through. Now, I like thinking, I saw this and I thought, that door is kind of like DSPy. It's a door to another dimension that we might work with optimizing. So let's sort of visualize this as this sort of third dimension here, this optimizable step. And let's cast this into a framework that we're all comfortable with as developers hitting LLM APIs. Consider the LLM as a black box. Let's make it very simple today. And let's say we're doing a very simple, this is even simpler than our build today, dope or nope classification problem. X goes in, Y comes out of our large language model. The pricing is way too high. Ooh, that's actually not that dope. So this is a terrible model. The concert last night was unreal. That sounds pretty dope. This is a pretty terrible model. And so the idea here is, can we do something to make this a little bit better without changing anything inside the black box, right? Of course, you can do lots of things when you get into open source models and fine-tuning through APIs, and you can do all sorts of cool stuff. But let's say we can't do any of that. Let's say that we actually just want to inject almost like, a LoRa matrix or something. We're just injecting this sort of precursor step. Let's call it DSPy. And what we want to do is we want to make this thing a way that we can now optimize what comes out based on what we put in. So let's resituate ourselves here. And let's consider that we have prompt response pairs. The way I like to think about DSPy is we're sort of adding control knobs in our optimizable step that we didn't have before. Okay, so we're now allowed to move these knobs and we can see, like, how did the response change? Is it better? Is it worse? Whereas if you just have a classic in-out black box, you're sort of stuck with only optimizing the words, the actual natural language prompt. So DSPy allows us to sort of tweak the input to get a better output. Very simple. Now we still have input-output pairs, keep in mind, but let's sort of bring in another layer to this. All of you are probably familiar with hitting the OpenAI API, sort of developer 101, how to start building with these tools. Now, if you're not a developer and you just use ChatGPT, you put text in and text comes out of ChatGPT. But if you're going to use chat style model syntax, rather than text in, text out, you put a list of chat messages in and you get a chat message out. This list of chat messages is going to have specific types of roles associated with each message. These roles you're likely quite familiar with are called the system, user, and assistant roles. The system level is quite important, and it does really matter what you put in it. How the LLM is feeling, where its expertise lies, exactly what kind of instruction you want it to provide, what instruction you want to provide it to follow the best practice rules of prompting. We really want to set the tone here in our prompts. And generally, this gives way when we're using a tool like LangChain or Llama Index or any of the infrastructure orchestration tools out there will generally have sort of baked in prompt templates, like the one we saw in our RAG system earlier. And these prompt templates are sort of serving that system level role for us. And maybe we have one-shot, two-shot, few-shot learning and all of that. But let's focus in on kind of this idea of a system level prompt. If we kind of go back to our DSPy understanding, conceptualization, then our prompt here, we can kind of think of it as the same prompt that we're using in general. We might use something similar. And again, we can think about it in our sort of genius behind the door space as well, where we really want to kind of figure out how can we use this optimization step. So let's do a fun problem together called Dope or Nope. And the hypothesis here is that we can actually improve GPT 3.5's ability to analyze and quantify dopeness with DSPy. We're going to need a few constructs, really just two primary constructs here. The first one is called a signature. And the signature is going to include, much like a system level prompt, a description of the task. And much like a prompt, it's going to include an input. It's also going to include an output because there is data associated with the example you're going to see today. We're going to have input-output pairs. Now, as an aside, DSPy also seems to be able to handle unlabeled data and do all sorts of other interesting things as well. We're, again, building this from the ground up. Our dope signature is going to say something like, rate a sentence from 0 to 4 on a dopeness scale. And we'll let the LLM decide exactly what that means. But like, the audit was comprehensive. Okay, it's not dope at all. It's pretty, it's kind of dope. The certification was obtained. Okay, it's like, I'm not saying crushing it, right? I'm not saying like we saved a bunch of cash, but you kind of get the idea. If we were doing a dope, not dope, these would be dope. But maybe there are levels too. And so what we want to do is we want to kind of add these control knobs. And what we're going to do is we're going to break up this DSPy into two pieces. Instead of going into this DSPy, let's sort of break it down. We're going to go into our signature, and then we're going to have the DSPy tool that we pull out of our DSPy toolbox called Typed Predictor. And this thing's got a lot of the magic sauce in it here. This is going to leverage our prompt response pairs, and it's going to really kind of out of the box help us to do this optimization of our prompt response pairs so that we can nail the training set and do better on the test and validation sets. Very simple, very classic, very much aligned with everything you've done in ML to date. So let's see how it works on the inside. From dopeness data to what's exactly going on in typed predictor. Let's see how we can make GPT 3.5 even more dope with DSPy. Wiz, take it away, man.
Oh, yeah. Okay, so today we're going to be looking at the Dope or Nope DSPY program. So this is very much like a toy example for sure. Just want to get our feet wet with some of the core concepts of DSPy, so we can talk about them a little bit more in depth as we go on. The idea is we have a data set. This data set contains a bunch of sentences, and those sentences contain a bunch of ratings, and those ratings are between 0 and 4, where 4 is most dope and 0 is least dope. You can also see that we have some fire emojis that we could extend our example to if we didn't want the integer examples. We're going to stick with int because it's the most straightforward to understand, but the idea is we have this labeled data set. Now, what we also have is we have our DSPY notebook, and this notebook will be available in the YouTube comments. So check there if you're looking for it. The big idea with DSPY or DSPy is this is the only dependency we need because it comes with a bunch of other dependencies. So it's going to help us. It's going to grab OpenAI and everything like that. As the library matures, I'm sure it'll go through a LangChain llama index style break apart where we'll have different packages. But for right now, it's just one big ol' blob. Because we're going to leverage OpenAI under the hood, of course, what do we need? It's OpenAI. OpenAI is going to help us to generate, text as an LLM, a language model, right? So the thing about DSPy is that it doesn't need the weights. Now, we'll talk about in the future the set of circumstances where it can use the weights. So it's not like the model weight, sorry. So it's not like this is completely divorced from that, but we don't have to include the model weights, which is what makes this framework right out of the box so interesting and useful. Okay, so next we're going to set up our model. We're going to use GPT 3.5 Turbo. It's a classic, it's fast, it's cheap, but it's kind of like not great at every single task, as we'll see in a second. We can call our LLM as you'd expect, as is similar to other frameworks. We can just give it a string and we're going to get a response, right? So that's great. That's what we expect. Also, like some of the other frameworks, DSPy currently has a settings where we can configure our LLM to be, a default LLM, let's say. So the LM here, which is our language model, is going to be set to our LLM object, which we created, which is an OpenAI 3.5 Turbo model instance. So this is the idea. Whenever we don't provide a language model, DSPy has the ability to intuit or infer from our settings that we mean GPT 3.5 Turbo, which is dope, right? It's pretty good. Again, it's early days. Constantly, this library is being updated, so I'm sure we'll see some shifts in this as we go down the road. So now that we have DSPy and our model, we're going to get some data, right? So our data is going to be from our Dope or Nope data set. The data set's going to include 99 rows, which have ascendings, rating, and fire emojis. We're not going to be using the fire emojis in this notebook, though it would be fun to extend this to use them. There's not really a lot of change you'd have to do other than move this to fire emojis. You could represent it as a list, or you could just represent it as a string. LLMs are smart enough to figure it out. So you'll notice when I look through my data set, right, that I have, it's 4, 3, 4, 4, 4, 3, 3, 3, 3, you know, and then there's this shift where it goes to all ones. So what we're going to want to do, of course, is shuffle our data set so that the labels are evenly mixed together. We do not want the LLM to, you know, win because it always guesses one, quote unquote, right? So that's not what will literally happen, but the idea is, you know, we want to make sure that our labels are spread throughout our data set, even though our data set's very small. So what is a data set in DSPy? Well, a data set right now in DSPy is built of examples. So it's a list of examples, and examples have, you know, inputs, and then they have other fields. So you'll notice that we have this example. An example can be defined with any, you know, keys that you want. So sentence, you know, you could call this input, you could call it whatever you'd like. We're calling it sentence just for consistency's sake, but you'll see that we have a sentence, and that sentence is in our data set row as sentence. Then we have a rating, and that's in our data set row as rating. And then we're going to specify that the input, or the inputs, in case you had more than one, is going to be sentence, right? So the idea is that we want to indicate to this example object what the inputs are. This is going to help everything work together more smoothly in the future. So basically, we create a train set with 89 examples, and then a val set with 10 examples, and we're good to go. We can look at an example of each. The results were satisfactory is a 0 out of 4 dope, hard agree, terrible. And then the val set is a, you know, this is top tier. That's a 4 out of, you know, 4 dopeness. I agree. Top tier, that's got to be pretty dope. Okay, perfect. So that's our data set, which is just a list of examples that have different fields and that have specified inputs. Next, we're going to talk about the signature. The signature is kind of one half of the core to a program in DSPy. So that's simplifying a little bit. So you know, we'll talk about more advanced uses in the future. But the idea is that the signature is kind of like our prompt as well as our prompt signature, right? So the format that our prompt should be interacted with. So it's both going to define kind of the task, which is going to be in this doc string, and then it's also going to define what the inputs are and what the outputs are. So you can see here that we have this dope or nope, which is extending signature. We're going to give it this doc string, which is rate a sentence from 0 to 4 on a dopeness scale. And then we're going to provide a sentence, which is going to be a string, as an input field. And then we expect rating, which is an int, as an output field. And you can have more than one input and output field, totally fine. But the idea is that similar to other frameworks that have kind of like, you know, formatting enforcement and stuff like that, this is what this is being used for here. So that's our signature. We're both describing our prompt, right? So this is like the traditional prompt, right, that you'd expect. And then we're describing both what our inputs are and what our output should be. And why that's useful, we'll see in a second, right? So, okay. Next, we have our predictor. We're going to be using the typed predictor because we have this int. And the typed predictor is going to do some cool stuff for us, right? But essentially, where the signature is like the prompt and what we expect the inputs and outputs to be, the type predictor is the thing that understands what a signature is and can call the model in the correct way to get those inputs and outputs based on our prompt. So what does that mean, right? Well, what it means is that this predictor, which is separate to the signature, right, can take a signature and then build what is used to call the LLM based on that signature. So this is that splitting that we were talking about earlier, right? That partitioning of the two different pieces. This is the core thing, right? The predictor is an object that understands signatures and can use them as a template to call the LLM, and the signature defines the behavior we want, right? So this is like defining our behavior, and then our predictor is the thing that understands what that behavior is and how to get the LLM to produce it in grandiose terms. So what does it look like? Well, it looks pretty straightforward, right? So we have this idea of it has an instruction. we get a sentence, we want a rating, we've got sentence, we've got the idea of what sentence should be, what it should look like. That's great. We can provide descriptions if we needed to. This is great. Then we have our actual generate. So we call the predictor, right? So we've just kind of bundled it in generate label. So when we call generate label with a sentence, right, which is expecting as input, we get a response, right? And that response is rating equal 3. So it's done the thing, right? We have this rating, and it's got this int 3. So let's look at what the actual prompt was. Okay, so the actual prompt is rate a sentence from 0 to 4 on the Dopeness scale. Hey, that's familiar, right? That's exactly what we described in our prompt. Nice. And then there's follow the following format: sentence, sentence, rating, rating, respond with a single int value. Sentence, this is top tier, rating 3. So all of this, right, was added by DSPy. So we didn't do any of this. We didn't have to do any of this critically, right? And then we get our response. And that's the power of DSPy. And you'll notice here that we can just call the history of our LLM to see what it has done. So it's keeping reference to all of the things that it has done so that we can see them when we need to, which is very useful, not just for showcasing. Okay, so let's look at another predictor. We're going to look at the typed chain of thought predictor. And notice that, so to be clear, we're not going to use this predictor throughout the rest of the notebook, but notice how all we need to do is pass the same doper nope signature to this new predictor to get new functionality, right? We never changed that signature. It's the same signature we used with the typed predictor. And that's, again, this is the foundational thought of the DSPy, from my perspective, is this idea of, that signature is independent to how we want the, what we want the LLM to call. And so that's the idea. We set up a typed chain of thought predictor. We generate a label with it. We can both get the result, which is going to be 4, so it's a little bit off, and also the reasoning, right? So produce a rating. We first consider the impact of the phrase top tier, which implies the highest level of quality excellence. This phrase is commonly used in a positive context and conveys a strong sense of approval and admiration. Additionally, the brevity and simplicity of the sentence adds to its effective emphasis. Overall, the sentence is straightforward and powerful in its expression of high regard, right? So this is the same signature, right? We didn't change the signature at all. It's the predictor is able to call the LLM in a way that produces what we want. And of course, what we get, rate a sentence from 0 to 4 on a Dopeness scale. That's our doc string from our signature. Follow the following format: sentence, reasoning. Let's think step by step in order to produce the rating. And on. So someone in the YouTube chat, Srinivas, sorry if I'm saying your name incorrectly, says, so the predictor is like a translator of the signature intent into LLMs. I would say that's a good way to think about the predictor, yes. It is the thing that translates what we want or desired behavior into something that's optimal for the LLM. And we'll see in the future this extends past, right? It extends past just the prompt. We can use it with the weights too, in any case. But yes, that's a great way to think about it. So that's the idea. And what we can do is we can also optimize this predictor, right, using DSPy. And that's the beauty. Our signature stays the same, and then our signature or our predictor can be optimized to produce something that we want. Okay, so we look at our modules. Our module is like a program, so we're going to build a program. Program is loosely synonymous with chain from frameworks like LangChain. So what we do is we create a doper student, and we'll say why this is a student in a second, which extends module. We do some init stuff, and then we're going to give it a generator or a predictor, which is based off of our signature. And then we're also going to give it this forward method with, it's going to take a sentence, it's going to predict, and then it's going to return the prediction. So yes, Alex in YouTube chat asks, what about more free text? We can set up a signature for free text outputs, absolutely. So we can make it a string instead of a int. We're just showing an example where how powerful we can conform the output to exactly what we want. But we can do loose, generative style content as well with DSPy. Okay, so all this is, right, and you might notice, hey, this is basically PyTorch, and it is basically PyTorch, and that's by design. But the idea here is pretty straightforward. We have this forward pass. The forward pass is going to get a prediction, and then it's going to return the prediction to us. Let's frickin' go. Okay, so now we have the ability to evaluate, right? Evaluate, it does what it says. We evaluate. So we're going to evaluate using our val set. We're going to give it one thread to work with. We're going to display the progress. And, of course, we're going to go to display table equals 10 so we can display all our results. Rustum asks in the chat, does it handle specific LLMs? We don't have to worry about that. We will provide the LLM through our settings or when we call our predictor, and that will take care of it. So, yes, it adapts to the LLM in a way that makes sense when we optimize, when we compile. Okay, so for our valuation, we need a metric. We're just going to use exact match, right? So it is the rating that we predicted, the actual rating. It's just easiest this way, right? Everyone gets it. And then we're going to evaluate our dope or nope student on exact match. We can see that it gets 30% of the guesses correct. It's mostly just guessing threes like a lad. Okay, so that's cool. So what about optimization? Well, with optimization, we have a couple of different strategies. I'm going to talk very briefly about labeled few shot because it does what it says. Labeled few shot provides a few labels, a few shot prompt engineering basically, but in a more systematic fashion. What we do with this optimizer is we can compile our student model with it to produce like a model that has learned, right? That has been compiled, that has been optimized, which is going to be our compiled pipeline. The big idea is that we provide our student program, right, which is this, what we built above, so this program here, and then we provide our train set. And our train set, of course, is our training data. So then we can evaluate, we can see that a very small but real increase to 40%. Right? So we did get better with few shot. That's the expectation. We love it. Okay. And then the big one, right? So this is bootstrap few shot. Bootstrap few shot takes in that exact metric, and then it's going to actually do some computation to determine what kinds of examples we should use. And so what this does is it combs through our examples, and it bootstraps additional examples if they're needed. Again, this is going to take our student program and our train set, and then we're going to move to our evaluation with this compiled DSPy through Bootstrap, and we'll see that we get a market improvement to 60%. And it's not just guessing 3 all the time, right? Which is awesome. So, and the things that's getting wrong make sense, right? So the presentation was outstanding. It does sound kind of dope, but not really, right? So we have more to do here. But the idea is that with very few lines of code, thanks to this optimization and compilation process, we can get a market improvement on a closed source LLM, right? Just by supplying our training data. And we can look at what's happened is that we have this respond in the following format, and then we have our examples that have been provided, and then we have our output, and we can see here that there are 16 examples being provided in each LLM call, and the examples look like things like this tea is piping hot with a rating of 4. And with that, I'm going to pass you guys back to Greg. Before I do, though, don't forget to like, comment, subscribe. We're here every Wednesday. We're going to do a few more DSPy events as we go forward, so to dive deeper. But for now, I will pass you guys back to Greg.
Awesome. Yeah, thank you for that walkthrough on exactly how this is working behind the scenes, Wiz. You know, we saw that the DSPy control knobs here really come down to the predictor. While the signature remains unchanged, the predictor is really the thing that translates the desired behavior that we want to do our task well into something that is more or less optimal for the LLM. And so we can kind of think about DSPy as being broken down into this signature and predictor. And the predictor is what's leveraging our prompt response training pairs. And it's really cool that we can even do this on a closed source black box LLM. So in conclusion today, we saw that, DSPy, sort of the long-term vision, is this sort of scalable, explainable, adaptive NLP with retrieval. And they really want to unify retrieval-based and in-context learning. And now, prompting, fine-tuning, reasoning, and RAG. They want to unify everything. And so there's a lot to unpack in DSPy. At the core, what we're really doing is we're specifying so that we can optimize problems across these patterns with access to whatever data we have, including and not limited to the prompts, weights, and more. And we saw even better performance today, again, on a closed source LLM without using this one-shot, two-shot, few-shot classic prompting approach. So I want to kick off the discussion, Wiz, with a little kind of overarching question here. We could use multiple inputs, multiple outputs. We could use open source models, closed source models. We could start doing some tuning. We could have access to different things, use all these different patterns. Is the right focusing lens to think about DSPy the task level, or is there sort of, is there something else that we can sort of offer for people to take away when they think about how should I use this?
Yeah, for right now, what I'll say is that the task level seems to be the most easily grokkable and easily portable option. So what that means is when you have these smaller models or cheaper models like GPT-3.5 Turbo, or your kind of your sub-billy models, right? This kind of framework can be very effective at getting that model better at these tasks. When it comes to things outside of that, I would be more hesitant to use DSPy as the only part of your solution. But for these task specific goals or applications, it's just such an easy lift to get in there.
Yeah. All right. Nothing like easy, cost-effective performance improvements. So, okay, let's see. We got a lot of great questions in the prompt. Pardon me, is it in the end just another template formatting library that sends prompts to the LLM?
Yes, but it's better than that, and it will. Okay. So no, it does go beyond just wrapping a prompt, right, and then sending it in. So from that perspective, I have to say no. In order to be, honest to the library, is it so much better that it's the only thing that matters at this moment in history? No. Does it have the potential to grow into something that does, become significantly or meaningfully different from its the other solutions in its ecosystem? Yes. This is the good way to start for these task specific things, or for these kinds of examples that have very straightforward data sets, or we can create information that very straightforwardly helps us optimize. It's incredible, right? But unfortunately, as soon as you say those words, we're kind of in the realm that we are with the rest of the LLM ecosystem, right? Which is that we're benchmarking these systems. Everything like that is an incredibly difficult task in and of itself, right? So how can we leverage that effectively? They are doing work on it all the time, and it is getting better over time. So it right now, I would say it's a notch above, but it has the potential to be many, many notches above.
Yeah. So leading, and let's see if a startup comes out of it. We're going to try to see if we can get, Omar on the next event, and see if we can get some insider information on this too. So keep the tough questions coming, guys. Matul has a couple questions here. How does DSPy contrast with p-tuning, the PEFT technique exactly?
Yes. So the very easy answer is that they're not trying to achieve the same things. P-tuning, if people are unaware, is a method of fine-tuning, or this parameter efficient fine-tuning, right? Which is going to give us these little weird packages that we amend to our input sequences, and then we can train those to get better results. I think at the end of the day, DSPy is meant to be an abstraction away from that, so a level above that kind of process, where we're not going to deal in the nitty gritty of an actual implementing the actual fine tuning methods ourselves. DSPI will sit on top of that process. So in that sense, the contrast is that this is like one step, it's one level above the actual PEFT technique. If that helps, Matul.
Meta PEFT. Okay, nice. So then can we see the final prompt that was used to sort of optimize this after doing this sort of,
Yeah.
DSPY stuff? Okay.
You know it. So that's in the history that we showed, which includes like those examples. That's what it came up with. That was the final prompt.
Piece of cake. Okay. Yeah. Will it help to make it easier if we swap out and test different LLMs as they will handle potentially different specific prompt formatting? What do you think? Like, if I was doing this and I was like, oh, okay, GPT did this, should I try like a Anthropic Claude? Should I be swapping out pieces of this as I'm doing this?
That's the beauty. We compile for the LLM that we're using. So what does this mean? Can you just hot swap LLMs on the fly? No. Can you, though, recompile your existing program with the new LLM in order to get an optimization that is now tailored to that LLM? Yes. So the idea being that if we swap LLMs, we will have to recompile when we swap. But that's it, right? What we get the assurance of is that even though we've swapped our LLM, that recompilation process or reoptimization process is going to make sure that the new normal is suited to that LLM specifically. So yes, it does make it easier, and I guess even better than easier, it helps assure that the quality is going to be as high with the new LLM as it can be, thanks to this recompilation process.
Okay. So just double clicking in on that with this next question, like the specific formatting techniques that you might need for Claude or for Mistral, like this is all sort of baked in and it's handled like as soon as you kind of set this up with DSPy. Like you don't really, again, don't hot swap, but this is being taken into account as we set this up.
I need to look literally into the source code in order to say for sure, but my intuition is that this is being handled by the library. I will look into the source code to verify that that's happening, specifically when it comes to like XML versus JSON questions.
Okay.
But that is my understanding, yes. It's
all right.
like LLM aware.
Got it. And then last question for today. And then, it seems like we are getting a bunch of great questions. I think there's ways we can take the DSP idea to the next level. And I think we should maybe start a little DSPy series here. Final question. Can we combine this with LangChain, or is this included in LangChain today?
So I mean, sure. Right, so you can use DSPy to get like an optimized prompt, and then you can put that into LangChain or whatever you want to do. You can tie these things together, but I would focus on thinking them for right now as mostly separate entities. We'll see what happens as time goes on in the ecosystem, how well they'll play together and how well they should play together and everything like that.
Nice. Okay. Well, that's a wrap for today. Thanks, Wiz, for walking us through the foundational DSPy. And next time, maybe we'll cover a little bit of RAG, a little bit of fine tuning, try to get some ideas into how we can handle these more complex generative AI patterns with DSPy. So look out for that. If you enjoyed, obviously like and subscribe, and you'll stay in touch for the upcoming events. We're always here on Wednesday at 1 p.m. Eastern. If you've been engaging in the chat today, seeing the folks around, you can also find them in Discord. And so if you're not there yet, we'd love to have you jump in and start building, shipping, and sharing with us. If you're ready to sort of accelerate your generative AI career and your ability to build production grade LLM applications, check out the most recent updates to our AI engineering bootcamp. The next cohort starts in August, and DSPY will be amongst many other topics covered in the bootcamp. Cohort 4 is going to be rocking, so definitely check that out and put your application in if you're interested. Finally, if you have any other questions, comments, feedback for us, please let us know. We'd love to hear from you. If there are specific tools you'd love to see that are as hype as DSPy, let us know. And if you've got a connection to the creator, Omar, definitely reach out and make the connection for us. Otherwise, I'll be reaching out cold. So thanks, guys, for joining us. DSPY, is it advanced prompt engineering? Yeah, kind of. But is it more? Yeah, kind of. Stay tuned for next time. Until then, we'll keep building, shipping, and sharing. And we hope you do the same. Thanks, everybody. We'll see you next week. Bye, guys.